On slide 19, we show the output that we see when we run this little program. A circle is drawn, and then a scaled circle is drawn, then a square is drawn, and a scaled square is drawn, and finally a polygon is drawn, and a scaled polygon is drawn, and at that point the program is over. But we have a puzzle here, because the destructors for circle, square, and polygon should be displaying these little messages, tilde C for circle, tilde S for square, tilde P for polygon, and we're not seeing those. So we have a problem here. Let's think about this. Now, in the base class, in shape, we declared draw as a virtual function. We declared scale as a virtual function. We declared rotate as a virtual function, so that if we have a base class pointer pointing at a derived class object, the correct derived class draw or scale or rotate function is looked up at runtime. But here, when we say delete SV sub I, which we should have SV sub I here instead of *IT, that will delete the memory that was allocated with new and invoke the destructor for the class. But we didn't specify any destructor for the shape class at all, and we certainly didn't specify the destructor for the shape class as virtual, which would cause the correct derived class destructor to be called. So we need to fix that flaw, and we show that on slide 20. If you have an abstract class, you have to specify a destructor for that class, and the destructor has to be virtual. So here we've added to our shape class a destructor for the shape class, and we specified that it is virtual. So now, when we have a pointer to a shape, and we do a delete on that pointer, not only will that deallocate the space that the pointer is pointing to, but it will also invoke the correct derived class destructor that that shape pointer is actually pointing to. So if we have a shape pointer pointing at a circle, and we say delete the pointer, that will invoke the circle destructor. If we have a shape pointer pointing to a square, and we say delete the pointer, that will invoke the square destructor, and so forth. So this is the only correction that we need to make in our class hierarchy, and when we compile and re-execute the program now, we will see a circle drawn on the screen. Then the circle will be scaled by a factor of 2, and we'll see that circle drawn on the screen. Then we have the delete of that pointer. So notice that we see the derived class destructor called first, and we see tilde C indicating that the circle destructor has been invoked. And then the base class destructor is also called. So we see the tilde shape message displayed by the derived class destructor. Remember, we said that when you call constructors for objects, that the destructors for those objects are called in the opposite order. The same thing is going on here. When we create a circle, that first invokes the constructor for the underlying class shape, and then invokes the body of code that remains for the circle class. All right, so the inner shape is constructed first, even though in this case the shape class doesn't actually have any constructors. The inner shape is constructed first, and then the outer circle, the higher level circle, is finished being constructed. So when we delete a circle, that is, we delete on a pointer to shape that's pointing to a circle, that's going to call the destructor for the circle class first, and then the destructor for the base class shape next. Okay, so we've drawn a circle, we've scaled the circle and drawn it again. We've deleted that pointer, which causes the derived class destructor to be called first, and then the base class destructor to be called. And now in the second iteration through the loop, we draw a square, we draw a scaled square, and then we delete that pointer. All right, so now we have a pointer to shape that's actually pointing at a square. So that's going to invoke the square class destructor first, followed by the shape destructor, the base class destructor. And similarly then for the polygon. The polygon is drawn, the polygon is scaled by 2 and drawn again, and then we delete the polygon, which invokes the polygon destructor, and then the base class shape destructor. The circle class destructor doesn't actually do anything other than display a message. Likewise, the shape base class destructor doesn't do anything other than displaying a message. And the square destructor, although we didn't implement it, doesn't do anything but display a message. However, for the polygon destructor, remember that we looked at that back on slide 14. The polygon destructor is doing something very important because we allocated these two int arrays with the addresses of the first elements of those stored in the members XA and YA. So we had better have our destructor delete the array XA and delete the array YA, or we will have created a memory leak problem for ourselves. It's a very common bug, and it's something that I continue to do, I'm embarrassed to say, to forget to declare your base class destructor as a virtual function. And this often leads to memory leak kinds of problems. Here on slide 22, we're showing a reminder of our employee, manager, CEO class hierarchy with constructors for each one of those. Remember that an employee has an ID number, a name, and a rate, and so the constructor for the employee class initializes those private data members. The manager constructor also needs to be given an ID number, a name, and a rate as arguments, as well as a job title and a budget. The manager constructor simply passes down to the employee constructor the initial values for the ID, name, and rate. So there we see that when we construct a manager, the first thing that happens is that an employee is constructed, and then we complete the initialization of the manager. So in essence, when we construct a manager, we're constructing an employee first, and then finishing constructing the manager. And continuing on with the CEO, when we construct a CEO is a manager with the addition of a profit target and a bonus percentage. So the constructor for the CEO class first constructs the manager, which first constructs the employee and then completes constructing the manager. And when the manager part inside of the CEO is finished being constructed, then we complete constructing the CEO by initializing the profit target and the bonus percentage. Okay, so when we invoke the CEO constructor, that first builds the inner employee part, and then completes building the inner manager part, and then completes building the CEO part. So you want to think of this as being sort of like Russian dolls here. When you construct one of these, you start with the innermost doll and you add the shells for the outer dolls. That's construction. And when you destruct from the outside in. That is, you disassemble the nested dolls starting from the outside and working your way in. This is the same idea as far as the hierarchy of how constructors and destructors are called.